Hello there, the Math Dog here. In this video I'm going to look at an introduction to multiplying fractions. So I'm going to use some visuals and then I'm going to show you the quick way to multiply fractions, and I'm going to go through several different things here, including using multiplying fractions in probability questions. So when we added and subtracted fractions, we found the least common multiple or least common denominator before we could add things together, because we had to get our units the same size. Just keep in mind you do not do that when you multiply fractions, nor will you do that when you divide fractions. So let's get started. So the word of in a math problem usually means multiply. So for example, 1/2 of 2 means 1/4, I'm sorry, 1/4 of 2 means 1/4 times 2. The dot here meaning multiplication. 20% of 10 means 20% times 10, and 20%, if you know, is 0.2 times 10. So of means multiply almost all the time. So let's first of all think of multiplication as a stretch or shrink, or a magnification or a shrink. So one way of thinking of what we do, what we mean when we say 3 times 5 is we're taking 5. Think of it on my number line here. I'm taking 5. Here's 5 units, and I'm stretching it. So if I doubled it, that would take me to 10. That's going to be 2 times 5. Then if I take it 3 times, so that's doubling 5, and now tripling 5 puts me at 15. So one way of thinking of multiplication is in this case, is a magnification. We're magnifying it 3 times. Now you could also shrink it when you had to multiply by a fraction less than 1. So let's take 1/3 of 12. So here's 12 on a number line. So if we think of 12 as a length here, let's use a color we can see. So think of 12 as a length here. If I take 1/3 of 12, I'm shrinking it by a factor of 3. So I can break 12 up into 3 parts. Okay, so that's 4, that's going to be 8, and this is 12. So if I'm shrinking it to 1/3 its original size, it's going to be right here. This is 1/3 of 12. So you can think of this as a shrink. So sometimes we also call this a dilation. So 1/3 of 12 can be thought of as a shrink or dilation. So our answer is going to be less than what we started with whenever we take a number less than 1. Alright, now we're going to use a box model to picture the multiplication of fractions. I don't like to get too involved in this, but I will try to show you a visual of a way to think about what's going on when you multiply. So remember, 1/2 times 2/3, that's 1/2 of 2/3. So I've got a box here. The whole box represents 1 or 3/3. That's 1 whole. So 2/3 would be this area right here. That's 2/3 of a whole. Okay, so that's 2/3. Now I'm taking 1/2 of that. So 1/2 of that would be, let's get to a regular pen here. 1/2 of that would be right here. So our final result is this, which is, if this is 3/3, this is 1/3. So our answer here is going to be 1/3. So again, I take half, here's 2/3 of a whole. I take 1/2 of that, that's this, and in terms of 1 whole, this is 1/3 of 1 whole. So our answer is 1/3. So let's do another example. So here I broke in my 1 whole, this is 1 whole, up into 5 equal parts. So each one of these is 1/5. Okay, so let's take 1/5. Let's shade that in. Okay, that's 1/5 right there. Okay, now I'm taking 2/3 of that. So what I'm going to do is I'm going to draw a dashed line here, or a dotted line. So 2/3 of 1/5 would be this. So I'm going to shade this in now. That is 2/3 of a fifth, because this is 2/3 and a fifth. I'm going to outline in yellow. So this is 2/3 of a fifth. Now in terms of the entire box here, I've now split this box into 15 parts. So this is part 1, part 2, out of 15 total parts. So my answer is going to be 2/15. 2/15 out of 1 whole is my final answer here. And again, remember, times means of. 2/3 of 1/5. Okay, one final example here. So 3/2 of 1/4 times means of. So this is a box that's broken up into 4 equal parts. Okay, so 1/4 would be right here. Now I'm taking 3/2 of a fourth, so 3/2 is 1.5 times. So if I break this up like this, that's going to be, this is 1/2 of a fourth, this is 2/2 of a fourth, so 3/2 of a fourth has to be this area that I'm going to shade in. I'll use yellow this time. Has to be this area. Let's use not the line, let's use a freehand here, yellow. It's got to be this right here. So this is, again, that's a fourth. This is 1/2 of a fourth, 2/2 of a fourth, so 3/2 of a fourth is right here. Okay. So now notice I broke each fourth into halves. So I'm going to continue to do that. I want a line this time though. Back to lines. Okay, there we go. So I'm breaking each fourth into half. So now notice I've got 1, 2, 3, 4, 5, 6, 7, 8. So this is 1 whole. It's also 4/4. It's also 8/8, and I have 3 of those 8 shaded. So my answer is going to be 3/8. Now the box model can illustrate what we're doing, but it's not a very efficient way to do things. So we're going to move away from this as quickly as possible. But I'm going to have you do one practice question here. So stop the video. This is broken up into thirds. This is 1 whole. This box represents 1 whole. So I want you to copy this box and demonstrate the multiplication 1/2 times 1/3. And then when you're done, turn the video back on. Okay, so let's start with a third. So this is 1/2 of a third. So here's a third right here. Okay, so now you're taking 1/2 of that. So we're going to split that in half. Like so. So we're talking about this area right here. All right, well, let's get the base unit or the denominator unit. So I'm going to divide all these into, take 1/2 of each of these. So now I've converted 3/3, which is 1 whole, into 6/6. Well, of those 6 pieces, 1 is all we're dealing with, this 1 right here. So this would be 2, 3, 4, 5, 6. So we have 1 shaded piece. So my final answer is 1 out of 6, or 1/6. Okay? So let's move on. So now let's use multiplication of fractions to solve probability problems. Actually, let me go back. I'm going to go back and now show the quick way to do this. So notice we did the box model to get these answers. And notice, so all you have to do is do this. 1/2 times 2/3. I could multiply across, that's 2 over 6. But that can be reduced because I can divide 2 into both of those. And actually you could have canceled this out here if you want to. Well, that's going to be 1/3. So notice I get the correct answer by just multiplying the numerator with the numerator and the denominator with the denominator. So 1/3 is the answer. So back on this question, I could have just gone 2/3 times 1/5. 2 times 1 is 2. 3 times 5 is 15. So notice I get this method, this algorithm or method of multiplying fractions gives me what the box model gave me. So that's how we will multiply fractions going forward. So now the last one in this example, I have 3/2 times 1/4. That's 3/8, okay, which is what we got with the box model. And then the practice problem, 1/2 times 1/3. Well, 1 times 1 is 1, 2 times 3 is 3, so we get 1/6. All right, so we use multiplication a lot to solve probability problems. Probabilities are chances, okay? Probability of an event, of an impossible event is 0. The probability of a certain event is 1. So probabilities fall between 0 and 1. So 1 is like the sun burning out. Tomorrow's basically an impossible event. And the chance of you not paying taxes when you're adult is basically an impossible event. So impossible is 0 probability. Certain is 1. So now let's do a probability question here. So suppose you flip a fair two-sided coin and spin the spinner. So a fair two-sided coin has a 50% chance or a equal chance of heads and tails. Okay, then this spinner, notice, is divided into 3 equal parts. So the chance of red would be 1/3, the chance of blue would be 1/3, chance of green would be 1/3. So we're going to first draw a tree diagram showing all the possible outcomes here. So I'm going to start here. First I'm going to flip the coin. So either I get heads or tails. Okay, then I spin the spinner. I could get red, blue, or green. Likewise, if I got tails on the flip, I could then on the spin get red, blue, and green. So I have 6 different possibilities. I could get heads and red, heads and blue, heads and green, or tails and red, tails and blue, tails and green. So there's 6 possible outcomes. In this case, they're all equal possibility. There's an equal chance for each of those 6 outcomes. That's not always going to be the case, but it is here. So what's the probability of flipping heads and spinning red? Well, you can look at it in the table here. Heads and red would be right here, and that's 1 out of 6 ways of doing it. Now notice you can look at a table, but you could also go, okay, well the probability of flipping the coin heads is going to be 1/2. The chance of red is going to be 1 out of 3. Notice when you multiply those together, you get 1/6. Okay. All right. What's probability of flipping tails and not spinning blue? Okay. Well, tails would be, let's use yellow here. Tails would be this, and not blue would be red or green. So notice there's out of 6 different ways, 2 of those fit the bill. So this would be 2 out of 6. Okay. Now, if we knew that flipping tails, the chance of that's 1/2, and a chance of not getting blue would be 2 out of 3, we have this. And again, so if you multiply this out, you get 2/6. And by the way, 2/6 can be reduced to 1/3. Okay, so the probability either way you do it is going to be 1 out of 3 or 1/3. Okay. So now here's another problem using multiplication to solve a probability. Here's another problem using multiplication to solve a probability question. So suppose a jar contains 10 red, so I'll say 10R, 4 blue, and 12 white. Okay, now notice the total number of marbles here would be, let me do this up here, 10, 4, and 12. There's a total of 26 marbles. We need to know that. Okay, so there's 26 different marbles in this jar. So what's the probability of drawing red? Well, the probability of drawing red would be 10 out of 26. There's 10 ways to get red out of 26 total marbles. We'll assume the marbles are all the same size. They feel the same. You can't tell the difference unless you look at them. But that reduces because I can divide 2 into both these. So my probability is 5 out of 13. Okay, next question. So what's the probability of drawing a red, putting it back in the jar, then picking a blue? So probability of red is 4 out of 26. Okay, I'm putting it back in the jar, so now there's still 26 marbles, but now the probability of picking a blue marble is going to be 4 out of 26. Okay, so I'm sorry, so did I say first I'm picking red? So there's 10 red. This is a mistake here. Let's go back. So probability of picking red is not 4, it's 10. Okay, so that's 10 out of 26. Okay, I'm putting it back in a jar again, so there's 26 marbles still in the jar, but now I'm picking blue. The probability of blue is 4 out of 26. Okay, so literally we could do some reducing here before we get started, and that might help here. So 10 26, I can divide 2 into both 10 and 26, so that is going to be 5/13. And then I can divide 2 into 4 and 26, that's going to be 2/13. Well, 5 times 2 is 10, and 13 times 13 turns out to be 169. Okay, there are no common factors between 10 and 169 other than 1. So our probability is 10 out of 169. Alright, so now question 3. What is the probability of drawing a red marble, not putting it back in the jar, then picking a blue marble? So if you remember, there were 10 red marbles, so we're starting with 26 in the jar, so red, probability of red is 10 out of 26. Now we multiply that by the chance of picking a blue marble. Well, we took this first marble, this red one, and we threw it away. So now we only have 25 marbles left. So now chance of picking a blue, no blue marbles have been picked yet, so we have a total of 4 blues, so that's going to be 4 out of 25. Okay, so before I multiply this, I could reduce this to 5/13. Okay, 10 26 reduces 5/13, then 4/25. I can't do anything to that. So in the numerator, I'm going to have 20 here. That's the top, 5 times 4. And then 13 times 25. So that's going to be 15, carry a 1. So that's going to be 6 here. Placeholder 0. 3 times 2 is 6. 2 times 1 is 2. So we get 325. Okay. Alright, so now that actually, so 325, well, I know 25 goes in 325, and I believe it goes in, well, it goes in 13 times. So there's nothing I can do to reduce this actually. So we keep it at 20 over 325. That is our probability here. Okay, now why are we multiplying here? Well, let's go back, try to explain why we're doing multiplication by looking at this tree diagram. So the ways you could get tails here was heads and tails. But then for each head, you can break that up into 3 parts. So this is 1/2 here, and then this is going to be 1/3 for each one of these branches here. Well, that's going to be 1/2 times 1/3 again. So each way is 1 out of 6. Okay, so there's 6 possible outcomes. So we're applying the same principle here. It's just that it would be kind of messy to draw a tree diagram with all these marbles, but it could be done, and it's the same idea as what I did with the coin and the spinner. Okay, so last question. What's probably drawing a red marble now? Again, that's 10 out of 26. Okay, we're not putting it back in, we're throwing it away, so now there's only 25 marbles. But now what's the chance of picking another red marble? Well, we already picked one, so now there's only 9 red marbles, so this is going to be 10 26 times 9 25ths, which is 90. Well, actually I can reduce this again. Let's do that. Keep the smaller multiplications usually easier. So that's going to be here that's going to be 5/13 again, times 9/25. Oh, this is going to be nice here because I'm going to do it this time. I can reduce this way. 5 goes into 5 once. 5 goes to 25 5 times. So 1 times 9 makes 9. 13 times 5 is 65. So my probability is 9 out of 65 of picking a red marble, throwing it out, and then picking a second red marble. Okay, so now here's a practice question. We'll do it one thing at a time here. So suppose a jar contains 4 yellow, 3 red, 5 white marbles. So question 1, what is the probability of drawing a red marble? So stop the video, answer question, and start it again. Okay, probability of drawing a red is going to be 3. How many total marbles do we have here? We got 4 plus 3 plus 5. That's 12. So probability of drawing red is going to be 3 out of 12. But that can be reduced because I can divide 3 into everything here. So that's 1 out of 4. Okay, second question. What's the probability of drawing a red marble, putting it back in the jar, then picking a white marble? So this is called we call this technically sampling with replacement. Because after you pick something, you put it back in. Okay, so now answer the question, stop the video, answer the question, and turn it back on, see if you agree with what I got. Okay, so probability of drawing a red is what, 3 out of 12? We're putting it back in a jar, so we still have 12 marbles. And then the chance of picking white is 5 out of 12. Okay, so I could reduce it here. You could multiply across and get 15 out of 144, but you'll have to reduce that again. So I'm going to reduce it this way. 3/12, 3 goes to 3 once. 3 goes into 12 4 times. So this ends up being 5 out of 48. That's the probability. Okay. So now, what's the probability of drawing a red marble? Not putting it back, so this is now sampling without replacement, and then picking a white marble. So this is, we call this generally sampling, and I'm going to write without as WO, without replacement. So probability of red again is 3 out of 12. Okay, now I'm taking that red marble, I'm throwing it out, so now I only have 11 marbles left. Okay, then the chance of picking white again, I believe, is 5. There's 5 white marbles, so that's 5 out of 11. I can reduce 3/12 because I can divide 3 into both those. 3 divided by 3 is 1. 12 divided by 3 is 4, so I now have 5/44 is the probability of picking a red, not putting it back and picking a white. So notice that this actually is a little higher probability. 5 out of 44 is a better chance than 5 out of 48. So the without replacement increases our odds of having that event occur as opposed to sampling with replacement. So the last question again is, so what's the probability of picking a blue marble now? Okay, we don't have any blue marbles. Alright, so I fixed the question. It's now going to be white marble, so I made a blunder there. So what's the probability of drawing a white marble, not putting it back in the jar, then picking another white marble? Well, the probability of white is going to be 5 out of 12 initially. Okay, so then I'm not putting it back in, so now I only have 11 marbles, and if I had 5 and I picked one already, I have 4. So this would be 5/12 times 4/11. Well, 4/11 there can be reduced because I can divide 4 into 4 once, 4 into 12 3 times. So end up with 5/33. That's the probability of picking 2 whites in success right next to each other without replacing the first white marble that I drew out. Alright, so now we'll talk a little bit about multiplying mixed numbers. So when you have a mixed number, it has a whole number part and a fractional part. So you have to convert these to what we call improper fractions before multiplying. Improper fractions like 4/3. It's a fraction where the numerator is larger than the denominator. So the quick way to do a conversion here is you take the whole number part times the denominator plus the numerator here. So 5 and 1/4 would be 20 times 4 plus 1, which is 21/4 times 2/3. Which then I could reduce this actually several ways. I mean, I could make this 42/12, but I have to reduce it. So I'm going to divide 3 into 21 and 3, so that 3 goes into 3 once, 3 goes into 21 7 times. Then 2/4, well, 2 goes into both those, so 2 divided by 2 is 1, 4 divided by 2 is 2, so I end up with 7/2. That's an improper fraction. Okay, so I want to now convert this to a mixed number, so the way I can now convert an improper fraction to a mixed number is I divide the denominator into the numerator. So 2 goes to 7 3 times, 3 times 2 is 6, and I get remainder 1. So this is the whole number part, 3. The fractional part is 1 over a denominator of 2. So let's just look at 7/2 a minute. So this is the way you want to do it, but you could also write this, okay, well this is 6/2 plus 1/2. Well, 6/2 is 3, so you could do it that way, but this is a lot more efficient. Now 5 1/4, why does this work? Why does it become 21/4? Well, you could do the same thing here. 5 is the same as 20/4 plus another fourth makes 21/4, but the way you want to convert is you go 5 times 4 is 20 plus 1 is 21/4. That's just so simple and fast once you get it down. Okay, and then just likewise 7/2, you divide 2 into 7, goes 3 times 2 is 6, remainder 1. So it is 3 whole number parts, 1 fractional part over 2. Alright, so the next example, actually before I get started here, I could reduce that. 6/9 is 2/3, so I'm going to write this as 2 2/3 times 3 1/5. So again, to convert a mixed number to a fraction, I go 2 times 3 plus 2, 2 times 3 is 6 plus 2 is 8, so that's 8/3. 3/5 is 3 times 5 is 15 plus 1 is 16 over 5. So unfortunately I can't reduce anything here, so I have to multiply 16 times 8, which is 128. So that's 128 over 15. Well, that's an improper fraction because the top is bigger than the bottom. So I'm going to write as a mixed number. I divide 15 into 128 using long division with remainders. So 15 does not go into 12, so it goes 0 times. 15 goes to 128. Well, I got to start making some good guesses here. Well, what's 15 times 8? Okay, that's 120. That's too small. 15 times 9 is going to be 135. That's too big. So it goes in 8 times. So 8 times 15 is 120. So I subtract, I get remainder 8. So this is going to be 8 and 8/15 as a mixed number. Okay. Okay, 2 practice questions on this. So do both the questions and then check your answers versus what I got. So stop the video, do the questions, and turn the video back on. Okay, so I'm first convert these mixed numbers to improper fractions. So 4 times 2 plus 1 is 9 over 2. Let's do a different color here. So that's 9/2 times, and 2 times 4 is 8 plus 3 is 11 over 4. Unfortunately, nothing I can reduce here, so this is be 99 over 8. That's an improper fraction. I'll change it to a mixed number by dividing 8 into 99. 8 goes into 9 once. 1 times 8 is 8. Subtract, that's 1. Bring down the 9. 8 goes into 19 twice. 2 times 8 is 16. So get remainder 3. So my answer is going to be 12 and 3/8 as a mixed number. Then the second question, 3 times 5 is 15 plus 2 is 17 over 5. And then I have times, 7 times 10 is 70 plus 1 is 71 over 10. So unfortunately, again, nothing reduces here. That's over 50. 17 times 71 That's 7, 1, placeholder 0, 7 times 7 is 49, carry a 4. 1 times 7 is 7 plus 4 is 11. So I get 7, 10, that's 12, 1. So I get 1,207. Okay, that's an improper fraction. To change the mixed number, I divide 50 into 1,207. Okay, 50 does not go into 1, does not go into 12, it goes 120 twice. 2 times 50 is 100. Subtract, I get 20. Okay, bring down the 7. 50 times 4 is 200, 50 times 5 is 250, too big, so it goes in 4 times. 4 times 50 is 200. Subtract, I get remainder 7. So this is 24 and 7/50ths as our final answer. Okay, moving on. So some area and volume questions. Well, the area of a rectangle is base times height, so the area of this rectangle has to be 4/7 times 2/3, which is going to be 8/21, and that's going to be, again, this is square units, this will be 8/21 square inches is the area of that rectangle. Volume is going to be length times width times height, or area base times height, but we'll just use here length times width times height as the volume for now. So doing that, the length is 1 3/4, which is, as an improper fraction, is 7/4. So I have 7/4 here, times the width is 7/8, times the height is 5/6. So I've got 3 multiplications to do here this time, and unfortunately nothing reduces. So 4 times 8 is 32 times 6 on the bottom, the denominator. That's 192. Then on the top, this is 49 times 5. That's 45, carry a 4. 4 times 5 is 20 plus 4 is 24. So we have 245 over 192, and that's going to be cubic feet. That's an improper fraction, so I'm going to divide 192 into 245. Well, it only goes once. So then that's 192, subtract, that's 3. Borrow here, 14 minus 9 is 5. So I get 53. So my answer is going to be 1 and 53 over 192 cubic feet, because volume is in cubic feet in this case. So volume is in cubic units. So this would be a cube that is 1 foot by 1 foot by 1 foot. So there's our final answer as a mixed number. Alright, so stop the video. And can't only see one question here at a time, so just do the first one, stop the video, and then check your answer versus mine. Okay, so here I'm going to take this is going to be, area is going to be base times height, so the area is going to be 5/8 times 1/3, which is 5/24, and that's meters. M for meters here, that's going to be square meters. Okay. Alright, now I'll stop the video and do the second question. This is 7/8, 2 1/4 feet, 3/5 feet. Again, 7/8 feet. So stop the video, work the problem, see if you get what I get. Okay, so here, 2 1/4 feet is 9/4 feet. So I'm going to take length times width times height, that gives me volume. Well, the length is 9/4, width is 3/5, and the height is 7/8. There's nothing I can reduce here, so I'm just going to have to multiply this out. I could go 27 times 7, or I could go 21 times 9. I'm actually going to go 21 times 9 here. That's 189 at the top. Again, why can I do that? Because again, the order that you multiply is not important. And then this is 20 times 8. 4 times 5 is 20 times 8 is 160. So I get 189 over 160. That's an improper fraction. I'll change it to a mixed number. I'll divide 160 into 189. It goes once. Bring that down here. So that's 29. So it's going to be, as a mixed number, 1 and 29 1/60. That's going to be cubic feet. Alright, let's do some recipe problems where we're actually going to reduce the recipe size. So I've got a recipe calls for the following: 3 2/3 cup. Let's try again. 3 2/3 cups flour, 3 teaspoons vegetable oil, 1 3/4 cups sugar, 5 1/8 pound chicken. So we're going to reduce the recipe to 2/3 of its original size, so we're shrinking it. So again, 2/3 of, remember of means multiply, how much of each ingredient will we use? Well, I'm just going to go this way. So this is, so I'm going to take 2/3 of 3 2/3, which is 3 times 3 is 9 plus 2 is 11. So that's 11/3. So this is going to call for 22/9 cups. Okay, let's write that as a mixed number, which again, when we're doing recipes, that is, mixed numbers are kind of helpful. So 9 goes into 22 twice. 2 times 9 is 18. Remainder 4. So this is going to be 2 4/9 cups flour. So 3 teaspoons of vegetable oil. So this is going to be 2/3 of 3. Now notice here that's a whole number. So I'm going to write 3 as a fraction here. 3 can be written as 3 over 1. And that's what I'm going to do here. So now that way everything lines up. So that's going to be 6/3, which is 2 teaspoons. So I need 2 teaspoons. I need 2 4/9 cups. Now 2/3 of 1 3/4 cup sugar. Well, 2/3 of 1 3/4 is going to be 1 times 4 plus 3 is 7/4. So that's going to be 14/12. Okay, that can be reduced. I could have reduced it here also. That's going to be 7 over 6. If I divide 6 into 7, it goes 1 time. 1 times 6 is 6. So that's going to be 1 1/6 cup sugar. Then 5 1/8 pounds chicken. Well, I'm taking 2/3 of that. 5 1/8 is 4 times 8 is 5 times 8 is 40 plus 1 is 41 over 8. Now I can reduce that a little. I'm going to do it here because the numbers get a little big. So 2 goes into 2 once. 2 goes into 8 4 times. So 1 times 41 is 41 over 12. So writing that as a mixed number, 12 goes into 41. 3 times. 3 times 12 is 36. Subtract. That's going to be 5. So it's going to be 3 5/12 cups. Okay, so that answers that. And here's a practice question for you. So a recipe calls for the following: 2 3/4 cups flour, 5 teaspoons coconut oil, 1 1/2 cups sugar, 3 3/8 pounds ground beef. We want to reduce the recipe to 1/4 of its original size. How much of each ingredient will you use? So stop the video, work the problem, see if you agree with what I got. Alright, so here I am going to take 1/4 of everything. 1/4 of 2 3/4, that's 2 times 4 is 8 plus 3 is 11 over 4, so that's 11/16 cups of flour. 5 teaspoons coconut oil, well that's going to be 1/4 of 5, which is 5/4. So as a mixed number, 4 goes into 5, goes once, 1 times 4 is 4, subtract the remainder 1, so that's 1 1/4 cups. I'm sorry, teaspoons. 1 1/4 teaspoons of coconut oil. Now, we take 1/4 of 1 1/2 cup sugar. Well, that's 1 times 2 is 2, plus 1 is 3, 3/2. So that's going to be 3/8 cups of sugar. And then we take 1/4 of 3 3/8. So 1/4 of 3 3/8, well 3 times 8 is 24, plus 3 is 27/8. So this is going to be 27/32 pounds of ground beef. And that finishes this question. Alright, so now I noted this, pay attention, because actually this problem, you have to be careful. So what I'm doing is, to solve this, box divided by 3/7 is 7/8. Well, I need to solve for box. I need to get rid of this division by 3/7. So the way you get rid of division, the opposite operation is multiplication. So what I'm going to do here is I'm going to literally do this. I'm going to take this, so I'm going to now multiply it by 3/7. But then what I do to one side of an equation, I have to do to the other. So I have to multiply the other side by 3/7. So dividing by 3/7 and multiplying by 3/7, those operations cancel out. So I'm left with box equals, the 7's here cancel. That's 7 divided by 7 is 1. 7 divided by 7 is 1. That leaves me with just 3/8. And my answer is box equals 3/8. So again, I'm using box here. Usually we use like an X, same thing. Like that. Box and X, same thing. It's an unknown. It's what you're trying to find. Okay, then the last example here. 2/5 of what number? Of, again, is times. 2/5, bring it down. What number? I'm going to use box here again. That's what I don't know. Is means equals. So I'm just going to say also, I told you of is times. Almost all the time when you in a math problem we see is a good number, let's say at least say a good number times, that means equals. In this case it means equals, so we have this. So 2/5 times box equals 3/10. And the way I'm going to solve this for box is I'm going to get rid of the 2/5 here. What I'll do is I will multiply both sides by the what's called the reciprocal of 2/5. So I'll multiply by 5/2. Okay. Now, why do I do that? Well, notice if I multiply 2/5 by 5/2, that's 10/10, which is 1. So this now becomes 1. Okay, well, 1 times anything is itself, so this just leaves me with box. But again, what you do to one side of the equation, you have to do the other. Again, it's like a balance. If I have something balanced, and if I'm going to say triple this side, I have to triple the other side also to keep it in balance. So I have to multiply both sides by 5/2. So I'm left with box equals, that is 5/2 times 3/10. That's 15 over 20. Excuse me, that can be reduced. Could have reduced it right here, but I'm going to reduce it here this time. So I divide both top and bottom by 5, and my answer is going to be 3/4. So box is equal to 3/4. So in other words, 2/5 of what number? Well, 3/4. If I do this, better give me 3/10. Well, notice that 2/4 could be reduced to 1/2. 1 times 3 is 3, 5 times 2 is 10, so it checks out. Okay, last thing on this video is these two practice questions. So go ahead and do them, and then stop the video, do them, turn it on, see if you agree with what I got. Okay, so the first one we just got done talking about. What I'm going to do is I'm going to now undo the division here. I'm going to multiply by 2/3 both sides. So that leaves me with box because division and multiplication cancel out like that. So box is equal to, notice, oh wow, 3 divided by 3 is 1. So that's 2/5. So my final answer should be 2/5. Now you could have gone, okay, you didn't have to reduce first. That's 6/15 if you don't, but then you can divide 3 into top and bottom, which is 2/5. The last question, again, of means times, is means equals. So we have 3/4, 5/6, and what number is my unknown? I'm going to call it box. Okay, so to solve for box, I need to undo this multiplication. So to multiply both sides by the reciprocal, and by the way, that's spelled reciprocal, like that. So I need to multiply both sides by 6/5. Okay, so that becomes 1 because 30 over 30 is 1. So I'm left on the left side with box equals, now I could reduce this or I could just multiply out. That's 18/20 if I just multiply it out. And notice I can divide, they're both even numbers, I can divide 2 into them. That's going to be 9/10. So my answer is 9/10. And this concludes the video. So if you liked this video, found it informative, please give it a thumbs up or a like, and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you. I hope this was helpful.